ABC. This is covering circular functions, and it's a big recap of year 11 stuff, which in term 3, that was one of the hardest topics for most students to cover. So one of the first skills in exercise 6A is to cover conversions, degrees to radians. The formula is quite simple. It's over here, and I'm going to write it down. If you want to convert degrees to radians, we know there's a property of 360 degrees equals 2 pi, which I'll explain soon. So therefore, from 360 to 1 degrees divided by 360, and you end up with pi and 180. So if you want to convert degrees to radians, times it by pi and 180, and you will then convert it to radians. Similarly, the other way around. Divide both sides by 2 pi to get the 1 radian. And 360 divided by 2 pi ends up being 180 over pi. So if you times any radians by 180 on pi, it will convert it to degrees. Now, let's see if you guys remember or understand why is 360 degrees equivalent to 2 pi. So those who are listening in, which I think it was 3 here and maybe along the way. Krish, do you know why 2 pi is equivalent to 360 degrees? Yes, so we know that full circle, that is 360 degrees, correct? Where's the 2 pi come from? Do you know? No, really? What about the other 2, 3 students? Sima, were you also part of this or no? Yes. You are? Cool. I'm just going to ask you a question then. Do you know where the 2 pi comes from? So we know that 360 degrees is the arc. So you're going around the circles, 360 degrees. Where's the 2 pi come from? Do you know?
Pi is 180, and so 360 is just 180 times 2. 5 times 2.
Yeah, I guess my first question is, how do you know that pi is equal to 180 degrees? Oh, yep. It is based on that, but why is it pi is equivalent to 180? Where'd that come from? Somewhere had to start off somewhere, right? Okay, it's okay. You don't really need to have that deep understanding. They probably just want you to know this bit. But for those who aren't sure or understand why, the first thing you learn in circular functions, it's called unit circle. Ever wonder why it's called unit? Unit means 1. So it's saying no matter which circle you come up with, imagine it's a perfect circle and it's a unit of 1. Now, if it's a unit of 1, you see, when you measure 2 pi, students don't know the difference between radians and degrees. Degrees is the angle. Radians is the distance around the circle. So when you say 2 pi, you're talking about this, the distance around that shape. Now, back in year 8, you did learn, I don't know if they taught you the proof to it as well, as to why it's pi times diameter, but let's just ignore that bit. We know that pi times diameter will tell you the circumference, which is the one in blue. Diameter is twice the radius. But if it's a unit circle, no matter what unit you're referring to, it's 1 unit. But if it's 1 unit, can you see why it ends up being 2 pi? So no matter which unit circle you're talking about, the distance around that circle is 2 pi distance. And when I say distance, I mean like it could be 2 pi centimeters, 2 pi millimeters, 2 pi meters, 2 pi kilometers. That's what it means. So now we know that the distance around the circle is 2 pi distance. That's how far it is. But then an equivalent to it is if you rotate it in terms of angles, the angle has a relationship to the distance. So 360 degrees is the angle, and that's why we say, actually, 360 degrees as an angle matches with the distance around the circle. Okay, so when you make a certain angle, you also make a certain distance as part of that circle. That's what it means. So the difference between radians is a measure of distance, and then theta is the measure of angle, how much you're rotating. Okay, that's the difference between the two. That's more of a deeper understanding, but if you didn't get that, all you needed to know for exercise 6A, how to convert. Yeah, so here's an example. If I wanted you to convert 60 degrees into radians, the rule says times by pi and 180. So you just do times pi over 180. 60 and 180 cancels out. That's why you end up with pi over 3. Okay? And then same thing with radians. If you want to convert radians to degrees, times by 180 on pi, and then you would work out as well. So if I gave you 3 pi times 180 on pi, the pi's cancel out. And then 3 times 180 is 540. Okay? Cool. That's exercise 6A. Moving on to 6B. So now that we got the unit circle in theory out of the way, let's see if you remember. So in a unit circle, here we go. We're going to draw a circle again. So the things that you understand now is the distance around the circle is 0 to 2 pi. And Samar was saying before 180 degrees is pi. Great. We've got a visualization. This is pi on 2. And this is 3 pi on 2. Okay. If I picked a coordinate on that circle, say this point, has an x coordinate and a y coordinate. Last year, you would have learnt what x equals to and what y is equivalent to in terms of trig. So you can use your year 9 trig from here. What does x equal to again? Hands up if you remember. What does x equal to? So when you put a coordinate here, it creates an angle. What was the x coordinate equal to again? Cos of an angle. Fill this in if you didn't know. Cos of the rotation. If you did cos of that angle, that will tell you the x coordinate. If you do sine of the angle, that will tell you the y value. Okay, so sine represents the y coordinates and cosine represents the x coordinates. Let's take an example. I already got it here actually. I wrote xy can be written as cos theta sine theta. Let's see if you can just read the unit circle and understand what it means when you type on your calculator back in year 9, sine of 180 degrees. Here we go, sine of 180. So you think about 180 degrees, this is 180 rotation. So I rotate around the circle, I rotated 180 degrees, and I end up at this spot. See that? Starting from 0, rotate 180 degrees, I end up at pi. So when you say, what is sine of 180 degrees, what's the answer? What's sine of 180 degrees? Since I know I'm at this spot, that's the spot I'm at. 0, because remember, at this point in a unit circle, that is -1, 0. Because you're 1 unit to the left, that's your x coordinate. Your y coordinate is 0. So when I ask you sine of 180, I'm saying, what's the y coordinate after rotating 180 degrees? So if you rotate 180 degrees, the y value at that point is 0. So naturally, you can say, yep, that's 0. Now let's visualize the next one. Cos means the x coordinates after rotating 270 degrees. Here we go, let's rotate. That's 90, 180 degrees, 270. This is where I'm at. I'm right at this particular spot. What is the x coordinate at this spot? Cos of 270, Una? 0. Very good. This one's 0, -1. Because it's 0 for the x, but the y value is -1. So when you say cos of 270, it should be 0, and sine of 270 should be -1. That's what all this means. This is 0. What does tan mean again? So if x is cos, y is sine, then what is tan? It's going back to remembering from last year. So if x is cos, y is sine, what is tan? Who remembers? Ooh, close. It's the other way. Y over x, how do you know? Rise over run. So think about a triangle. Theta, tan is OR, yeah? Opposite of adjacent. But opposite, can you see that's the sine value divided by the cos value? Because if you did SOHCAHTOA, SOHCAHTOA. TOA is O over A. So O is the Y divided by A, which is X. And Y over X, back in year 9, what does that remind us? When you have rise over run, what does that tell us? Gradient. So every time you rotate, there must be a line from the center that tells you the gradient. So let's rotate. Tan of 270 degrees. Here's the line from 0 to here. That's my line. That vertical line. What's the gradient at this point? Undefined. It's a vertical line. Gradient of that line is undefined. Whereas if I asked you, what is tan of, say, 45 degrees? You see tan of 45 degrees will be around there. That's a positive gradient. Tan of, say, 130 degrees is in this direction. That's going to be a negative gradient. So your answers for tan is just simply finding the gradient. That's what it means. And then lastly, cos of 2 pi. What's cos of 2 pi? So 2 pi is over here. Cos is the x values. So the x values must be, let's go with Erwin. So right at this point, what would cos of 2 pi be? What would the x coordinate be at this point? Close. No, unit circle. So unit circle means that it's one distance away. So this coordinate must be 1, 0. Very good. So if it's 1, 0, the x coordinate is? What's the x coordinate? 1. So therefore cos of 2 pi is asking what's the x coordinate at this point? That'll be 1. Yeah, but if I said sine of 2 pi, if I asked you sine of 2 pi, then it would have been 0. Yeah? All right. That's the interpretation from last year. Okay? What did you need to know from last year as your times tables equivalent? You needed to know this. You have to memorize all that. That is a prerequisite if you're doing circular functions, that at bare minimum exam 1, you walk in, they want to know that you already know these tables off by heart. Okay, so there's many ways to do it. You can do the triangles, the equilateral and the isosceles triangles to remember all 15. On the next page, I did show you my way of how I teach the students. So feel free to use this one if that helps you to memorize or whatever method you prefer. But no matter how, every one of you needs to know all 15. Okay, so there's 3 functions, sine, cos, tan, and there's 5 special angles. So 3 times 5, 15 exact values you must memorize. Okay, here we go. Here's my way of memorizing this table here for you. On the next page, what's this hand thing? This hand method, the first one I found on YouTube, and then the other one I made up, and it seems to work well. So here we go. Your 5 fingers, whether you're left hand or right hand, doesn't matter. From left to right on your hand goes from smallest to largest. Okay, so 0 degrees to 30 degrees to 45 degrees to 60 degrees to 90 degrees. Okay. If you want to memorize, you can memorize in radians as well. It goes from 6432, so it goes smaller. Because if you divide by a smaller number, the larger the number will be. Yeah? Now, how do you use this hand method? Notice it says sine on the left and then cos on the right. And inside the palm, which I used to get my students to write root over 2 on their palms and then just work with me as I go through this. But here's an example. If I want to find sine of pi on 3, what angle is pi on 3? 60. So it's this finger. So what you do is with your hand, drop down that 4th finger. So 1, 2, 3. This is my ring finger. So ring finger, I drop down to 60 degrees. Okay? And because we're looking for sine, remember sine is the number of fingers on the left side of that. So if I drop down my ring finger, I've got 3 fingers left over on the left, which is sine. I've got 1 finger for cos. So if I'm looking for cos, I've got 1 finger. If I'm looking for sine, I've got 3 fingers at the moment. Yeah? So this is the left side. So how do you answer the question? Sine has 3 fingers, so you do square root of 3 and then divide by 2. That's the answer. Sine of pi on 3 is root 3 on 2. Let's do another one, just so you get a vibe. Cos of pi on 2. Here we go. Which finger is cos of pi on 2? Where's pi on 2? The pinky. Yeah, so the last one down. So if I drop down the pinky, now cos is the number of fingers I have on the right-hand side. Now, assuming all of us have 5 fingers, Then if you have 6 fingers, it might be different. But assuming that you have 5 fingers, to the right, I have no more fingers. Can you see that? If I drop down the pinky, there's no fingers on this side. So when I say cos, how many fingers on the right-hand side? 0. Put into the formula. Root of 0 divided by 2 is 0. So cos of pi 2 would be 0. If you follow this method, you will be able to remember 10 out of 15 straight off the bat. So out of the 15, just following that method, you will remember 10 out of 15. Here's an example again. If I gave you sine of 30 degrees, let's test you now. Each and every one of you. Krish, what finger is 30 degrees? Second one. So it's my index. I cut that off. On the left-hand side, I've got sine, and on the right-hand side, I've got cos. Because I'm finding sine, how many fingers for sine? 1. So the formula is root of 1 on 2. It's half. So I'm looking for the number of sine fingers after I chop off wherever the angle is. Let's try another one. Similar. If I did cos of 30 now, which finger? Same one, so index is gone. How many fingers for cos? So it's square root of 3 on 2. So cos of 30 degrees is root 3 on 2. Erwin, let's try another one. Sine of 45 degrees. Which finger? The third one, the middle one. So I'm going to chop that off. Now I'm looking for sine. So how many fingers for sine? Root 2 on 2. Okay. Let's try another one. Let's go with Alicia. Cos of, am I done 30? Yeah, I've done 30. Cos of 60 degrees then. Which finger is 60 degrees? Good. The ring finger. So I chop this one off. How many cos fingers do I have? 1. So it's root of 1 on 2. It's half. What I've just done there with you and all of you there, if you've now memorized all this, just following that rule I just showed you, that's 10 out of 15. Cool? So that's what I found on YouTube in my first year when I was teaching this. And then I came up with this one. Because they were like, what about tan, sir? So I said, well, we know tan is sine over cos. So I realized it was just the number of sine fingers over cos fingers. So same thing again. The rule is just slightly different to this one. This one was square root the number of fingers and divided by 2. This one was count the number of fingers for sine, count the number of fingers for cos, and then square root the answer. So here's an example. If I want to do tan of 30 degrees, which finger is 30 degrees again? Index. Cut this one off. Now, how many sine fingers do I have? 1. How many cos fingers do I have? 3. Square root it. Now you can't square root 3, but you can square root 1. So it's 1 on root 3. Let's try another one. Tan of 60 degrees. Same thing. 60 degrees is my ring finger. Chop this one off. How many sine fingers do I have? How many cos? Square root it. 3 over 1 is 3, so the answer is root 3. If you follow that pattern, you will be able to memorize the last 5. So with just 2 rules, you will be able to figure out all 15 just from memorizing 2 formulas. One is root the number of fingers and then divide by 2. The other one is count sine, count cos, and then square root the answer. Okay? If you're wondering how you get this undefined one, well, that happens when you do tan of 90 degrees. Tan of 90 degrees, if you think about your fingers again, 1, 2, 3, 4, 5. That finger's gone. Sine has 4 fingers. Cos has 0 fingers. Square root it. 4 divided by 0 is undefined. You can't divide by 0. That's how you get undefined. Okay? So if you like that method, that's one way for you to memorize, and that's 6B. Exercise 6B requires that you need to know your exact values and hence answer these questions. So tan of pi 6, you should know the answer is 1 on root 3 just by looking at it. That's 6B. Cool? 6C. Oh, this is 6C. All right, 6C is one of the hardest ones. In year 11, that is. For year 12, this is now the expected. All right, let's see how many of you had learnt this well last year. So unit circle, now you know how to do it for 0 to 90 degrees, which means that you only know the angles for quadrant 1. That was from 0 degrees to 90 degrees because you did 30, 45, 60, 90. So you know all the exact angles just for the first quadrant. But the beauty is once you know the first quadrant, you can use symmetry properties to then bring it over to quadrant 2, to quadrant 3, to quadrant 4. That's how it works. I'm going to show you the logic to it. Cos of 30 degrees, let's go with what you just learnt. 30 degrees, which finger is that again? Index. So 1, 2, 3, 4, 5. Chop off the index. Sine has only one finger, so cos of 30 degrees is root of 1 over 2, which is half. Right? What does that mean? Sine is the y values. Unit circle, you have a distance of 1. So when you say sine, y value is half. Here's half. Where on the circle can you have a y value of half? Only these 2 points. These are the only 2 points where you get a half for the y value. Question is, what's x? So at this point, here's your x value. At this point, here's your x value. We already know this one's 30 degrees. That means in this triangle, it should be symmetrical to that one as well. This one's also 30 degrees. But if that's 30 degrees from this line, or this x-axis, and we know that from here to here is 180 degrees, it's just 180, take away 30. So that's 150 degrees. So that means, instead of saying sine of 30, which is half, there is also this point. How did I get to that point? I had to rotate 150 degrees to get to that same y value. There's 2 y values that you have the same value. But one was a rotation of 30 degrees. The other one I had to rotate until I had 30 degrees left over. That means I had to rotate 150. What you had to learn last year was that sine of 30 degrees was equivalent to sine of 180 minus 30, based on the picture I just shown you. That means sine of 150 should be exactly the same. So if you type on your calculator, sine of 30 is half, and sine of 150 should also be half. That's probably one of the trickiest ones last year for students to understand. It was that bit. But once students kind of got this, they're only used to degrees. You're not meant to work in degrees, you're meant to work in radians. Anyone know why? Why do we work in radians? Since the way I'm explaining it sounds more logical, you can work with degrees. Why don't we just work in degrees? What's the problem? What's the benefit of working radians? Because radians is the distance around the circle. So why didn't we just stick with angles? That would have been okay. Why did we go to radians? Anyone know? Here's the logic. For those who aren't sure. Notice this is 0, and then when you go half a revolution across, that was pi. Then you go half revolution back, it's 2 pi. But if you do it again, another half revolution, you end up with 3 pi. Then 4 pi. Now there's a pattern. 2 pi, 4 pi, 0. Pi, 3 pi's. What's the pattern? What do we notice? Yes, Krish? This is all adding by 2 pi, but that's all the even values are here. And all the odd values end up here. So even if I asked you what 99 pi is, what rotation, if I rotated around the circle 99 pi, you know that's an odd pi. You're going to end up exactly at this spot. So you know where you are in the circle. But if you try to convert 99 pi into degrees now, convert it to degrees, you would times it by 180 on pi. I don't know what 99 times 180 is. Actually, it's 1,800 minus 99, so 1,701. If I asked you before, instead of saying 99 pi, And I said, I rotated 1,701 degrees. Where am I? That's a lot harder to figure out than radians. This is why we work in radians, because you can figure out where in the circle you are, versus degrees. 99 pi is equivalent to 1,701. I don't even know where that is. But in radians, I do. Because radians is working in its nice whole numbers, odd versus even. Yeah? So that's why you had to learn from last year, you had to convert this now. Sine of pi on 6 is equivalent to sine of, now 180 degrees is the same thing as pi, minus pi on 6. And this is where the struggle was for a lot of students. Fractions. Where their fractions were strong and where they understood the unit circle, that point was what's tricky. Because what's pi minus pi on 6? Let's test your fraction skills now. 1 whole, take away 1/6. 5 pi on 6. And that was one of the biggest struggles for students. So if I asked them in year 11, I said, what's sine of 5 pi on 6? What they were struggling was to understand, how do I convert 5 pi on 6 back to this? If you can figure out that bit, then you know where you are in the circle. Pi minus pi on 6. This is pi. Minus, you're going smaller. So you have to be quadrant 2. That's why this was the hardest. Okay? So, let's do each of these ones. I just answer these ones here. These are all in degrees. Okay, you can work in the degrees to help you. Here we go. I'm going to do D with you. 210 degrees. Clearly, you've passed 180, but you had to move 30 degrees forward because 180 plus 30 will give you 210. Right, so it had to be 30 here, 180 there. So you're in quadrant 3. Now, if it's 30 degrees there, this triangle is exactly the same triangle as the one you figured out for sine of 30. You already know sine of 30 is half. But this point here at 210 degrees, what sign? Negative. Sine's the y values. Y value is negative. So we know it must be negative half because it's the same triangle. One's just positive half and the other one's negative half. So the answer for this one is negative half straight away. That was probably, if you had to learn anything for this exercise of this chapter and you didn't do it well last year, learn 6b and 6c. You need to know your exact values and then you need to know symmetry properties. That's the minimum. Okay? So you can do 330 as well. It's the same thing. That's from 360 going backwards. So 360 going backwards, 30 degrees this way. And I'm asking for sine. So again, it'll be negative half. And then you guys can try these ones here. Okay? All right. If you feel confident with that, just those bits there, then the final stage is, can you do these type of questions? Okay, that's 6C. So 6C, I'm going to finish there and I'll write up the solutions. But 6C means that you need to be able to work on these skills. If I asked you tan of negative 22 pi on 3, where on the unit circle are you? If I asked you for cos or sine of 3 pi on 2, actually that's pretty straightforward. Maybe we should have done like 3 pi on 4, something like that. That would have actually tested your understanding better. But that's what exercise 6C is about. Cool? All right, I'm going to pause the video and I'll write up the solutions, but I want you to practice depending where you're at. Is it conversions, 6A, B, exact values, or symmetry properties, 6C? Those are your 3. That's all from last year, and you may need to go back to year 11 stuff if you need to revise, yeah, because the next few lessons are going to be pushing on the fact that you know your exact values and symmetry properties. Otherwise, you'll struggle. But remember, the next lesson is your SAC, so you've got a bit of time. We're just going to move forward, and you've got holidays to try to catch up if you're behind. All right, answers are there, and let's stop the video.